Let us start ICSE Mathematics Class 10th, Chapter 9, Arithmetic and Geometric Progression. Number patterns. So the number pattern can further be divided in two parts. First is in sequence, a number which has got the pattern of a sequence, and other is not sequence. You can say a sequence has a definite order assigned by rule abric law, whereas not sequence means it may be increasing order, decreasing order, or mixed of it. Means both the increasing and decreasing order are mixed. So infinite, you see, further the sequence can be divided into part, that is finite sequence and infinite sequence. Finite sequence has got the last term, whereas infinite sequence has got no last term. And this type of sequences can further be divided into arithmetic progression, geometric progression, and harmonic progression. You see, the arithmetic progression has got the first term and the common difference between the preceding and succeeding terms, that will remain same. Similarly, for the geometric progression, the first term and the common ratio is there. And arithmetic progression, which is the reciprocal of it, is arithmetic progression. There is also first term and common difference. You see, the nth term of an AP can be given by A plus n minus 1 into D, where Tn indicate the number of the terms, A is the first term, n is the number of terms, minus 1, D is the common difference between preceding and succeeding term. L stands for the last term, that is also equal to A plus n minus 1 into D. The summation of n terms of arithmetic progression can be given as n by 2 in bracket 2A plus n minus 1 into D, where A is the first term, n is the number of terms, D is the common difference. And this can also be given by the second formula, that is known as last term formula. You see, n by 2 into first term plus the last term. Now, same number, there are some characteristics of the arithmetic progression, that same number will be added to each term, or same number will be subtracted to each term. It will not affect the common difference, means the same AP will be formed. Same arithmetical progression will be formed and the common difference will remain same. There will be no difference in the common difference. Now, while we are multiplying or dividing each term by a common number, then the common difference will also be multiplied or divided correspondingly. Now, the sum of the equidistant term from the beginning and ends remain the constant. From beginning and the ends remain the constant. Now the mean of two terms, that is, let it be the two terms are A and B. So there is A which is known as the mean of A and B, and you can justify it like this: capital A minus small a is equal to small b minus capital A. Now transpose it, you will get 2a is equal to a plus b. So a will be equal to a plus b divided by 2. Suppose you have to insert n number of arithmetic mean in between small a and small b. At that time, a will be, that b will be given by the formula that, you see the how many number of terms are there. You see a1, a2, a3, these are the n terms. Now including these two, that will be n plus 2 term. So the b will be equal to a plus n plus 2 minus 1 bracket closed into d. So d will be given as b minus a, means common difference can be given as b minus a upon n plus 1. So the a1, that means the first arithmetic mean, will be equal to a plus b minus a upon n plus 1. a2, that is a1 plus d, that is a plus 2 into b minus a upon n plus 1. Similarly, an, means the nth arithmetic mean, will be given by an minus 1 plus d. That will be equal to a plus n into b minus a upon n plus 1. Now proceed to for geometric progression. The geometric progression, you see there is a common ratio. So the nth term that can be given by Tn is equal to a into r raised to power n minus 1. Summation of n terms in geometric progression will be equal to a into 1 minus r raised to power n whole divided by 1 minus r, where r is less than 1. Summation of n terms, again you see a in bracket r raised to power n minus 1 r minus 1, where r is greater than 1, means common ratio is greater than 1. If there are infinite number of series, means infinity number of the series, at that time a upon 1 minus r, because this will be negligible and this will remain as 1 minus r. You see this formula, first one, where r is less than 1. Now geometric mean can also be given by the root of a and b. So a into r raised to power n plus 2 minus 1 is equal to b. So r into r raised to power n plus 1 will be equal to b by a. So r will be equal to b by a whole raised to power 1 upon n plus 1. The first geometric mean between the two geometrical progression will be given by a into b upon a into 1 upon n plus 1. G2 means the second geometric mean in the geometrical progression will be given by a into b by a power raised to power 2 upon n plus 1. Similarly, the nth geometric mean can also be given as a into b by a n upon n plus 1. Now the harmonic mean. If a, b, c are in harmonic mean, at that time the reciprocal of all corresponding parts will be in arithmetic progression. You see, a, b, c are harmonic progression. At that time 1 upon a, 1 upon b, 1 upon c will be in arithmetic progression, and a upon c is equal to a minus b upon b minus c, because we know that in arithmetic progression second term minus first term, that is 1 upon b minus 1 upon a, should be equal to the third term minus second term, that is 1 upon c minus 1 upon b. So a minus b upon ab will be equal to b upon c upon B minus C upon BC. A upon C will be equal to A minus B upon B minus C. Now, suppose we have to find out the harmonic mean between the two terms, that is A and B. So AHB in harmonic progression. So the reciprocal of it will be in arithmetic progression. 1 upon A, 1 upon H, 1 upon B in arithmetic progression. This implies that H is equal to 2AB upon A plus B, because we know that 1 upon H minus 1 upon A is equal to 1 upon B minus 1 upon H. So 2 upon H is equal to 1 upon A plus 1 upon B. So H is equal to 2A upon A plus B. Sure. Sometimes some questions are asked like there are odd number of terms, suppose 3 terms, 5 terms, 7 terms like that. So if we choose the terms like this, that A minus D, A plus A minus 2D, and A plus D, A plus 2D. So there are, I have written for 5 terms. So if you choose this type of terms, it will be convenient to calculate and to find the value of A and D. And if the number of terms are even at that time, here the common difference was only D. Now here the common difference will be equal to 2D if there are even number of terms. So we should start like this: A minus D, A plus D, A minus 3D, A plus 3D, A minus 5D, A plus 5D, A minus 7D, A plus 7D, like this. Now the same pattern can also be adopted in the geometric progression also. Any odd number of terms are, suppose there are odd number of terms, so you take the middle one, that is A. So A upon R, AR. A upon R minus 2, A plus A into R raised to power 2. If the number of geometric sequence of progression are even, at that time we will take like this: AR, A into 1 upon R, AR, A into 1 upon R raised to power 3, A into 1 upon R raised to power 5, here A raised to power A into R raised to power 3, A into R raised to power 5. So if you are selecting or taking or assuming the terms like this for even and odd I have just described, so it will be very easy to calculate the value of A, means first term, common difference or common ratio.